Hello,
Well,
everyone. Thanks for being here.
Sorry, Alexandre, let me jump in before you start your presentation.
Okay.
Thank you for being with us. I just want to remember people that if they want to ask questions, they can do so on the JNation YouTube channel or on the Slack channel, and I will pass the questions back to you. And I think that's all I have to say. Thank you, Alexander, for being in JNation this year. Alexander will be speaking about Kubernetes with us. And if you don't mind, I will pass the word back to you and you can start your presentation. Thank you very much.
Okay, thank you to Samuel. Thank you for all the organizer for inviting me this year at JNation. So thank you for being here and attending this presentation. I will present to you today 10 tips intended for designers who want to create cloud-native applications. Before going further, let me introduce myself. I'm Alexandre Touret. I'm French. You probably recognize my French accent. And I work at Worldline. Worldline is one of the is one of the payment and merchant leader in this industry. I live in Tours, in the south of France, not so far from the castle behind me. And I'm architect and developer. I've been using the Java platform for 2 decades now. I'm really interested about APIs and continuous integration. Cloud matters, of course. And the software craftsmanship. You can reach me using these pointers below. Before going further, I think it worth to explain how I use the cloud, how I use Kubernetes, and the context. So first of all, I'm not a cloud expert. I'm not a Kubernetes administrator. I'm just a designer or developer who try to design applications, develop them, and eventually push them to production. And I mainly use on-premise technologies, such as OpenShift. I will explain them later. So here are the technology I use during my last cloud project. And I will illustrate all the points, all the tips I will explain in this presentation by these technologies. First of all, Java, Spring Boot, of course. I also use Docker, then GitLab for the source configuration management and CI, CD, and so on. I also use Helm templates to deploy application to OpenShift. I also use public cloud providers such as AWS, Azure, and so on, but I mainly worked on OpenShift and premise cloud clusters. The first tip, and maybe the most controversial, the hardest to answer, is: do you really need it? Do you really need Kubernetes? Do you really need the cloud? And so on. Could be hard to answer to this question, and even more for IT engineers. For instance, if you have a small business application, I don't think it worth creating a cloud application and move to the cloud. Maybe could be your first step in your roadmap, but my opinion doesn't work because you need a lot of tools and a lot of technologies. I will address later. If you control all the scope, all the functional scope and technical scope of your application, for instance, if you have the same number of users all along the year, you don't have to deal with, for instance, Black Friday and so on. Maybe it doesn't worth using Kubernetes. And if you have already automatized everything using Ansible, Puppet, and so on, maybe the return of investment won't be obvious using this kind of technologies. Now, another question to ask to yourself is what are the non-functional requirements? It's really important. For instance, do you have constraining SLOs, service level objectives? If it's more than 99% availability, okay, go ahead, use Kubernetes, it works, definitely. If your system needs to be dynamically scaled, okay, go ahead. Frankly, it works. You are out of the box this feature to address this kind of requirements. On my side, I choose the deploying an application, my applications to the cloud because of these key features. Another point to address is about providing on-demand environments. If you have to deliver environments, when I say environment, I mean if you have to deliver a platform fastly, for instance, a sandbox for your customer to test only for 1 week, and we need this platform really fast only in 1 day, okay, you can use the cloud and you can use the Kubernetes and so on. It works. Another tip is about your skills and the skills in your organization and your team. I think that you have to choose either the blue or the red pill. Okay, the blue pill could be the development skills, your development stack, such as Java platform, Spring Boot, Quarkus, and so on. And the red pill could be the cloud administration, Kubernetes administration, Kubernetes expertise, and so on. In my opinion, you can have both, because both are really needs a lot of expertise, need a lot of training, a lot of work on each of them. So it's really, in my opinion, you have to choose one of them. If, like me, you took the blue pill, you can be autonomous on Kubernetes. You can deploy an application to a Kubernetes cluster. You can modify, create templates, and so on. But you won't be a Kubernetes expert. You won't be a Kubernetes administrator, and so on. So you must have in your organization a dedicated team which could help you providing support, training session, templates, getting started, and code reviews, and so on. It's really important to have either a team if you have big organization, or maybe 2-3 people in DevOps people in your team. So you need to have these skills in your organization. Because as a developer, you will have to know plenty of technologies. Java, of course. Spring Boot, Quarkus, why not? JUnit, because you have to invest a lot on JUnit, maybe Postman if you want to do functional tests, or Gatling if you have to do performance testing. Then you will have to know CI. You have to know CI and CI skill. You have to have CI skills such as GitLab on Jenkins. So by the way, you have to know Bash, how to make Bash scripts. Then you have to know that when you deploy your application to a cloud, your artifacts won't be jar file or WAR file anymore. There will be Docker images. Then you have to know Terraform, especially if you deploy your application to public cloud providers. You have to know Kubernetes, you have to know Helm, and then you have to know OpenShift or AWS and so on. It could be a big deal, really. So before taking the step, you have to check if you know enough, clearly. You have to make a list to say, okay, this technology I know, this one I know, this stack I know, this one I don't know, but I can have support. This one I don't know, I can have training session, and so on. It's really important to make this kind of matrix. Okay, what do you have in your organization? For instance, in my case, when I choose deploying an application to the code, we knew up to the Docker because we already use Docker on CI platform or on your local desktops. So we choose to say, okay, we said, I know up to this technology, up to this stack, but I can have support on Helm, OpenShift, and so on. So we choose moving to the cloud. If you think you don't know enough, maybe it could be interesting to make a roadmap to say, okay, first step is knowing Docker. Then I will deploy my application to a cloud, to OpenShift, for instance, creating Helm and so on. So it's pretty important to be sure that your team is stronger enough to deploy your application and to use the cloud. Maybe it could be better to postpone your cloud adoption, taking time to learn all of it and to having all of the skills. Another stuff to address, another tips is about the organization. It's not really funny, okay. However, it could be important to check that the organization is cloud compatible. Usually, when we talk about cloud deployment, we think about DevOps principle, DevOps pipeline from development up to production. However, in some case, you won't be able to do that. For instance, if you have to deal like at Worldline, if you have to deal with PCI DSS compliancy, which imposes to have a responsibility segregation. For instance, the developer can deploy to production. You can't implement pipeline. You can implement DevOps pipeline. And maybe if you are in a big organization, it could be really difficult to implement a change management. You have to be aware about this principle. I'm pretty sure some of you know it. It's about the Conway Principle. The Conway Principle says that an organization that designs a system will do copy-paste of its organization communication structure. Okay. I don't say that I have a big organization with silos and so on, so I won't be able to deploy to the cloud, but you have to be aware about your organization to succeed on your change management. So I strongly recommend that. I did that for my last project. So I checked the responsibility matrix, assignment matrix. It's RCI. RCI stands for responsible, accountable, consulted, informed. To be completely honest, it's boring, but it's mandatory to implement that and to check that you have this responsibility assignment matrix before going to production. So check first your current responsibility matrix for your older applications. For instance, if you have application one on JBoss server in a Linux box, okay, what is the current responsibility matrix? And with all the stakeholders, define a new one and say, okay, you are responsible for deploying to production, I'm responsible for develop, creating the artifacts and so on. By doing that, by checking with the oldest, you can say, okay, my organization is compatible. My organization is ready to adopt the cloud. It's really important to do that before going to production. It could prevent headaches, a lot of meetings, and so on. Now we will address some more technical fields. It's about the design, how you have to design your application. Maybe you know the 12 factors. 12 factors are 12 common characteristics for every cloud native applications. I won't address all of these characteristics, just a few one. For instance, what about the processes? You have to know that now you can't maintain, for instance, an HTTP session on the server side as you did a couple of years before. You can do that now. Why? Because you're using Kubernetes, your application will be scaled from 1 pod to 10 pod, and then this number of pods could be decreased to 5 pods and so on. So you can maintain on the server side some objects. When I say server side, I mean on the Java and the JVM, for instance. What about the dev pod parity? It's really important to know that because using the cloud, your infrastructure is immutable. for instance, you can modify a parameter directly on the server, in the file hosted in the server, and so on. You can do that. The configuration, I will explain this point later. It was already good practice to externalize the configuration in files or environment variables. It's even more important for cloud native applications. And finally, what I'll do is also this point later about the disposability. You have to manage the startup and the shutdown. It's really important for cloud native applications. So you will also have to know a bunch of Kubernetes component, Kubernetes principles. Sorry. For instance, for an API, which is the common use case for Kubernetes hosted applications, you will have to know that your Docker container is one in a pod, or one or two and pods. It doesn't matter. These pods are configured using a deployment. It's a Kubernetes object and are available using a one-robin load balancing and so on, using a service. Then if you want to expose this service outside the namespace, which is the boundary of your application, you will have to use a root. A root is an OpenShift object based on the Kubernetes ingress rule. If you want to reach components which are outside your namespace, you can use an egress. You have to use an egress, actually. Then if you want to autoscale your application, for instance, based on the CPU consumption, you can use autoscaler. And finally, if you have to deal with configuration, you can use a config map. I will also explain this point later. What about the application, and what about your application starts fastly? You have to know that the way your application starts fastly is the cornerstone of your cloud native application design. It's really important to know that, because all the stackability, the way your application could restart, could be deployed, could be handle errors, and so on, is based on this capability to start fastly. And to get the other way around, it's really important to manage the way your application shutdowns properly. When I say shutdowns properly, I mean your application manage all the current threads and wait for their terminations, and refuses the new ones, the new request. It's really important to manage that. So to do that, it's really important to choose your frameworks and to choose wisely your frameworks and target runtime platforms. In my opinion, you can't deploy the same technology you used before when you deploy the application on Linux boxes or using Java application server and so on, and do this and use the same technology and put them to Kubernetes because you have an existing Docker file and so on. It's really my opinion. It's only my opinion. Why I did that? Why I think that? Because in terms of cost, in terms of operation, could be really it would be really expensive. For instance, deploy a good all Oracle database. Do you think it's worthwhile? Do you think it's really relevant deploying this kind of database directly in the cloud, directly in Kubernetes? In my opinion, I don't think so. About the Java application server, the editors made good efforts to make their solution cloud compatible. For instance, if you check OpenLiberty made good efforts and have now a low CPU memory consumption, have a really fast startup. It's very more impressive for people like me who struggled 2 decades ago with the first version of a web server application server. So you have to check if you have to, when you have to choose a solution, when you have to choose a platform, a bunch of items. First, the fast startup. It's very important. As I said before, the shutdown handling. You must have this feature out of the box. The ability to be integrated into Docker and Kubernetes. The observability now is the new black. So you must have this feature directly out of the box in your solution. The memory CPU consumption should be really low. And last but not least, dependency patch management. We often forget this point, but could be really tricky to manage. When I say dependency management, you have to check if you're, for instance, if you create an application using Spring Boot, you have to update your application on a regular basis to prevent security and to integrate security flaws and integrate security fixes. And it could be the same for your Docker images, because your Docker images are based on, for instance, Ubuntu, Debian, Alpine. You have to build your Docker images on a regular basis to integrate all the security fixes. It's really important to address this point in your organization. In my opinion, it's really important to address this point before starting a project. So at Worldline, we discussed a lot between production and development teams. And we made a trade-off, clearly. Because usually developer using Spring Boot likes creating fat jars and deploying easily on their desktop and so on. It's easy using Bootpack. It's really easy to create Docker images. On the other hand, production at Worldline had the proper patch management for Docker images. So our Worldline production services provide standard Tomcat Docker image, and add this in production provide also a patch management mechanism for this Docker image. So we made a trade-off between the production and development teams, and the developers create WAR files, and then create a Docker image based on the standard Tomcat Docker image. It was a trade-off. We made this trade-off to have a proper patch management for your base Docker images. So you have to check that. What about the observability? As I said before, observability is it's very important for cloud native application. You must have this feature in your application and address all of these concerns. Address this point from the design phase. Don't wait to be in production. Could be Captain Obvious, but it's better to write it. So you will have to expose your system status for endpoints. Hopefully, using, for instance, Spring Boot, you will have out of the box all of these features. So be careful to use frameworks. Sorry. In Kubernetes, when you use Kubernetes, you will have to get these endpoints from the design, from the development phase, when you would like to deploy application to your development clusters. And the common probes to get are first the liveness probes, then the readiness probes. The first one say, okay, my application is live, and using plenty of parameters such as the URL, the protocol, the initial delay in second, and so on. And the later say, okay, my application is ready to address and to get new requests. So this configuration must be applied from the beginning of your development. And using Spring Actuator, it's really easy to do that. You will have to put your dependencies, Spring Actuator starter, if I remember well, in either your POM XML or build.gradle. Then you will have to put these properties in your application.properties file or in our variables. And then you will be able to use either liveness or both readiness state health indicators. You can do this feature as is, or you could override them. Or override an health indicator. It's really easy. It's really easy to do that. You will have to create a Spring component which implement health indicator. Then you will have to override implement two methods, health and the get health. In this example, I choose to override and to add a proper health indicator for MongoDB because we had how could I say a complex configuration of MongoDB. So we had to implement a proper health indicator for MongoDB, but it's really easy to do that. And beyond Actuator, you could add plenty of features and you could get all of the metrics to monitor your application. You could use Actuator ISIS. You could override it using Micrometer. Actually, Actuator is based on Micrometer, but you can add another dependency to add other metrics, such as your API statistic, the count of every API calls, the average of response time, and so on. You can so use a Prometheus time series database to expose all the metrics of your application, such as the memory and the CPU and so on. And you could use a Prometheus to request your data, but I strongly recommend using Grafana. It's easier to do that. You will have beautiful dashboards. And now, how to do that? How to implement that in your application? In Spring Boot, using Spring Boot is really easy. You will have to configure your application inside your application.properties file or application.yaml if you like YAML. Here I put the configuration in YAML. So you will have to enable the management endpoints either on web or JMX. Is the easiest configuration here. Then you will have to specify for each endpoint to say, okay, this one, the health, I show the data, it's enabled. I enable the probes. Then I enable also to monitor the shutdown, Prometheus, the metrics. I'll activate liveness, readiness probe, and so on. And finally, if I want to get more information about my API and the way I can get statistics of my REST endpoint, I could also add metrics configuration, micrometer configuration. Now, what about CI/CD? Oh, CI/CD was really important in the past for the application. It's even more for cloud native application because your platform is now immutable. And it's really CI/CD, and it's really the backbone of every cloud native application. I recommend integrating a bunch of items in your CI/CD pipeline. And you have to have a good skill on CI/CD before working on cloud native applications. You will have to use unit integration testing. You can also implement the performance testing, functional testing, and so on. In your CI/CD, you could also create your Docker image for every push. Then you can implement smoke test of your new fresh Docker image. Then you can implement a kind of continuous deployment of your develop branch or in your feature branch. Depends on what you need and what you can expect. You can also deploy on a regular basis in the same pipeline or another pipeline triggered by the main one. I don't know. You can deploy Helm charts. You can also deploy the release in another Kubernetes cluster, for instance, and so on. You can implement dependency track. It's better to implement it if you want to address the dependency patch management. You can so implement SonarQube, linter, and so on. But if you want to address cloud native application concern, you have to implement at least these features in your pipeline. Why to do that? Why investing on CI/CD? Because by automatizing at the most, you could have a good return of investment after when you want to migrate, to upgrade your dependencies and so on. For instance, we had an API using which are on the top of Spring Boot Tomcat, and we choose to upgrade Spring Boot. So I had to upgrade Tomcat from 8.5 to Tomcat 9. Then I choose to upgrade JDK from 8 to 11. I tested all this migration locally, then on development cluster, then staging. Only one day. Try to do that with from technologies such as when you want to, such as on the traditional virtual machine and so on. It's really it works. Definitely, we're working on Cicd. It works because of the migration, because of the upgrades and so on. What about configuration? Configuration could be really big deal when it's the first time you manage a Kubernetes deployment. You can deal with configuration on 3 and more ways, such as using environment variables for either configuration and config maps. You can use config maps too. And then if you have password and other, you can use secrets, which are quite the same about the config map, but the content is opaque and uncoded. So what about the environment variables? You can specify directly in your deployment Kubernetes object any environment variables you would like, such as here in this example, I decided to configure the good old Java options and using the new features of Java 11 and which were backported to Java 8 about the container support and the max 1% and so on. But you can do that on config map too. Config map is just Kubernetes object to store configuration, and it's reusable. So it's cleaner to use a config map instead of pushing environment variables directly in your container configuration. My opinion. But using container configuration, it's easier to modify it, to do a hot modification in OpenShift. What about configuration files? Okay. You can check that 12-factor, which said, okay, configuration must be provided as environment variables. But sometimes you have to deal with external frameworks which need configuration files. Sometimes when you have plenty of configuration properties, it's easier to put them in configuration files. It depends on your environment, of your operational tools, and so on. Hopefully, you can specify them as variables in config maps. It's easy to do them, and you can also externalize them. How to do that? You can provide your configuration files directly in a volume mount. It could be either persistent volume or a directory mounted directly in the container. It depends on the size. It depends on the size of your configuration files. And it's really easy to specify them in the config map directly. For instance, here I said this myconf. I put all the files stored in this folder, which is available in my Helm chart. By using that, I will get all the files stored in this directory, and this file will be available in this config directory. So my application could get this file then. How to externalize values? It's a good practice to extend the values of your configuration files. So you can do that on in your Helm chart files. For instance, here I externalized the max replicate using a simple syntax, using code and values and a configuration tree. And this configuration tree is available in the values.yaml file. And you have the same configuration tree here. So during the deployment, you will have your M chart and your values.yaml. And all the values YAML configuration data will replace the template when the application is deployed. It's really easy to do that. When you want to go further to say, okay, my application properties, my configuration files are also templates. Because I want to externalize from the Helm chart all the configuration. So you can do that with using the Helm template functionality. An example here, I put for the application properties. Yes, it's spring-oriented. You can use a template to say, okay, my application properties here, here's a template. So all the values provided in the values.yaml will replace this keys. An example here, I put in the application properties these value keys. And then I put on the values.yaml file all the regarding configuration values. What about the binary files? Binary files could be also tricky, but it's really not. When you want to create, when you want to put a binary file, for instance, a GKS, a key store, or trust store, to reach external APIs, you have to put this key and get in the same way the binary file and then encoded it. Last but not least, it's about the logging. It's really important to address this point during your development and not waiting the production deployment. You can easily do that in the console using kubectl. Okay, for development purpose, it's okay. Not for testing, not for production purposes. You can use, hopefully, log aggregator using, for instance, ULK from Elasticsearch. So, by the way, the Docker container output stream are std out and std in. It's really useless to set up a file output stream. You probably know that, but sometimes we can miss it. So I wrote during my 2 projects a bunch of best practices about logging. I will present a few here about you. It's really easy it's really useful to indicate in your log files all the container information, such as the image name, the container ID, and so on. The Kubernetes related information also, the pod IP address, the pod ID, namespace. Could be, and it's really important to have this information. For instance, if you can reach an external service, if you can reach this service, you have a timeout. Could be really useful to have all of this information directly in your log files to create then a firewall rule, for instance. Fortunately, Log4j and other frameworks integrated Docker and Kubernetes support in their functionalities. If you want to go further about logging, you can first add logbook framework. Why integrated logbook? A logbook is a framework provided by Zalando. It's open source, and logbook helps you identifying the related information for the API calls, such as the caller ID, the correlation ID, the request data, and so on. And you could override it, activate it using properties. It's really useful for API project. And if you want to go even more deeper, you can use distributed tracing. Why? If you have microservices-based architecture, could be nice to track all your API calls, for instance, from the API endpoint to the database or to another external services, which is in your namespace, and so on. You can do that using open tracing. Open tracing is available out of the box in, I guess, in Quarkus, and you could add it as a dependency in a Spring Boot-based or Spring Cloud-based application. It's really easy to implement that. after adding the dependency in Spring Boot and putting a bunch of properties, all your API or your transaction will be logged. And using open tracing, you could use also Jaeger, for instance, to get all the transaction and to check the duration. You can check also the status code. You can check the SQL queries on the database and so on.